Hello everybody once again, and welcome back to How to CMake Good. This is part 2D. We're going to continue talking about arguments to functions, and we're going to do that with a practical example, a real-world example. I'm going to re-implement something I've already done and walk through the process of how it was done. So the example in this case comes from CMake RC, which is a project you can go use yourself. It's a resource compiler for CMake and C++. What I want to do is add test cases to check that the code works. So here's my pre-populated directory of tests. I have a CMake lists where I will add the tests, some test executable main files, and some resource files that will be used to test the code. I'll drop right in on the simplest. We have simple.cpp, of course. It simply includes CMRC. IOStream declares the resource library, opens a file that has been compiled in, and prints the contents of that file to standard out. Now, it's opening up hello.txt, which we can see it right here. It says hello world, one line, that's it. And what we want to do is to check that this is what is printed out by the executable. I'll start by simply defining an executable for simple, and also define the resource library which will go into it. That's the definition of the resource library. Let's compile it. Got a typo. Looks pretty good. Let's define the test executable. That will compile our simple.cpp. It did not find the include. We need to link it. Compile. Oh, my resource library has the wrong name. It has to be simple, like that. Now, it compiles and links. Let's try to run that executable. cd build tests, simple test, and it prints hello world, just like we expect. Of course, ctest still doesn't see any tests. Let's add one. Add test, simple test, just like that. This tells CMake to generate a test called simple, using simple test as the executable to run. We'll run CMake, run ctest again, and there is our simple test. It's still not testing what we want though, because the simple executable is just going to print whatever's in this file. We want to make sure that it says hello world. Let's do that with a test property. Test simple property. And the regular expression will be hello world, which will match the test output that we expect from the simple executable. In the build, run ctest again, it passes, and if we tweak the test text inside of the file, rebuild, run ctest, it failed because the regex did not match. So we can tell that our test is working. Now there's other options to CMRC that I want to test. Let's add another resource library. The exact meaning of these arguments isn't important for this video, but note that I want to test this whence argument. The resource library will compile and link correctly, but we'll need an executable to test it. Let's add another executable. The executable for this one is called whence.cpp. It opens up a different file and prints that file's contents, just like simple.cpp. So we're going to need another test. Whence test with whence.cpp, then add test whence, and the test will be whence test, and then set property whence test property pass regular expression, and the content of the file it's printing is, let's open it up, I am a file. Let's set that as our regular expression to pass. We'll compile. The test name is not whence test, it's just whence. The test still didn't link because we haven't linked in the resource library. Whence test private rc whence. We'll compile it again. It links. Let's try the test. It works. You've probably noticed that this is quite a bit of boilerplate, and these two blocks are very similar. And you'll notice that I made a lot of mistakes while doing it. Typos, naming, and it's all around an error-prone process. This is the perfect time to introduce a function. Function CMRC add test name, main source file, and pass regex. So for each test we'll generate a resource library, CMRC add resource library. We'll call it RC and test name, so it'll be the name of the test prefixed by the word RC for resource. The namespace argument will just be the test name. Don't worry about what that means, it's not relevant for this video. And of course, we have a resource file. Then we add an executable. We'll call it based on the test name. The main source file will be the one that gets compiled. We'll link the test executable with the resource library we generated. We'll add a test. These two arguments are the same. This one's going to be the name of the test. This one's the name of the executable, which is the test. They just happen to be the same in this case. And we set the pass regular expression. Now, this block can be replaced with a call to CMRC add test. And what are the arguments? Name, source file, resource file, and a pass regex. The name of the test will be simple. The name of the main source file is simple.cpp. The resource file will be hello.txt. And the pass regular expression is hello world. I'll compile, I'll run ctest, and our simple test, now defined with this CMRC add test function, passes. Let's do the same with the whence test. CMRC add test whence.cpp. The resource file is this, and the pass regex is I am a file. Now we can delete this block and compile and run ctest. But we have a test that failed. No such file or directory, subdir b, file.a.txt. So the test whence.cpp tries to open this file, but it doesn't exist. I won't explain exactly the reasoning, but this is because we haven't passed the whence argument to CMRC add resource library. So how do we do that? Well, let's just add another argument, whence arg. Whence will be whence arg. And the whence from before is subdir a. Compile. We have an error because we're not passing a whence arg here, but it's required. Well, what's the whence here? It's empty string, I guess. Compile. And we're back to working again. But this is pretty ugly, and it's not clear at all what the relationship between these arguments are. It would be better if we could do named arguments and optional arguments. The good news is, there's a way to do this exactly. We have functions like setProperty, which take these pairs of arguments, almost like they're keyword arguments. We can emulate this behavior in CMake using CMake parse arguments. CMake parse arguments is a little more complicated. First, we'll take off all these arguments that we have named in the function definition, and we'll set some locals. The first one, we'll call it options. The next one, we'll call it args. And the third one we'll call list args. We'll explain all of those as we go along. The first argument to CMake parse arguments is the mode. The mode you'll generally want is parse argv. And then the number of arguments in argv to skip. We don't want to skip any arguments, so I'll pass 0. The third argument is the variable prefix. I'll just use test for now. The fourth argument is a list argument, which represents the options that CMake parse arguments will parse. We'll pass in our options setting. It's empty, but that's okay. The next argument is the args option, and the third is the list args option. We'll talk about the difference between those very soon. I'm going to comment out the rest of this function for now so we can do some debugging and look into what's going on here. So we have CMRC add tests. It takes no options, no arguments, and no list args at the moment. And we can print out what we're passing in for each one. Firstly, know that CMake parse arguments sets an option called unparsed arguments. This is the arguments to the function that did not get processed by any of these options we passed in. So let's loop over those. For each arg in lists, and the variable name is this prefix, test, underscore, and then unparsed arguments. And we'll message those out. Run configure. And here's the arguments that we passed that did not get parsed by CMRC add test. I'll message something at the top so we can delineate different invocations of CMRC add test. Here's the first call, and 1, 2, 3, 4, 5 arguments we passed in, just as we passed them down here. They've been maintained the order that we passed them in as well. That's important. So the first thing we'll want is a name for the test, and that would be a regular arg, not an option and not a list args. So in args, I'll say name, and I use all caps as the keyword specifying convention of CMake. If I run configure, nothing's changed yet. Go down to our calls. Here's our name, so I'll put name as an argument before it. I run configure, and now 1, 2, 3, 4 arguments to CMRC were unparsed. Not the 6 that we've passed here. We've passed name, simple CPP, hello txt, hello world regex, and an empty string. Simple CPP and afterwards were printed as unparsed. CMake parse arguments has parsed these 2 arguments. So how do we get at the value? Well, just like we said, CMRC sets variables prefixed by the prefix argument here. So message CMake parse arguments takes this all caps name, prefixes it with the word test and an underscore, and sets a variable based on what it parsed for that argument. Run configure, And the first call says the test name is simple, just like we passed here, name simple. For the second call, test name is, there's nothing there. We haven't set a name here, so I'll set a name there with name. I'll run configure, and test name is whence. I'll put these in single quotes just to help distinguish them in the output. And then the test name, in single quotes, is whence. Now we also have a source argument, so let's add one of those. Args is a list, so we just add another argument, just like that, and we'll print that too. Just like with name, the keyword source in all uppercase has been prefixed by an underscore and the argument prefix, which is specified here. Run it, empty. We need to specify the keyword argument, source, and source. Run configure. Source file is simple.cpp, and source file is whence.cpp. Let's lift these prints above the loop, just to organize it better. And we'll change called CMRC add tests for test, name. Run it, and there's our output. Called CMRC add test force test simple. Source file is simple.cpp. So we have to handle these unparsed arguments as well. We're passing in a resource file path, and it sounds reasonable to me to use the word resource. Well, let's add resource to our list of args. Parse it. The resource file is no longer unparsed. Let's add another message. Run it. And the resource file is the resource that we passed in to CMRC add test. Let's add one more for the pass regex. I'll call it pass regex and put that on both. The argument name, of course, is pass regex. Run it. And we've still got one more unused argument in the second call, but not in the first call. So what do we need? Well, we don't need a whence argument for this, so we'll just delete that. We need this to be the whence, so I'll prefix it with whence and add another option up here called whence. Run configure, and we have no more unparsed arguments. So what's common is that if you don't accept any arguments other than what you specified here, it's good to loop over and message warning. Instead of just printing a status, warn the user that they've passed an argument into your function that you don't expect, and they probably didn't mean to. So now we've parsed all the arguments, we need to do something with them. So let's duplicate this logic, but use it on our parsed arguments. I'll add a resource library, RC, and then the argument that they've passed, using this syntax generated by CMake parse arguments. So we're generating a resource library, templatized on the argument name, using the argument name, and passing in that whence value from the argument that we passed up here. We'll also need an executable, and of course, pass in our source. I'll link this executable with our generated resource library. I'll add a test based on the test name. And now what we want to do, we set property on the test for the regular expression that they passed us. Let's compile. It didn't even change anything. And if we run ctest, we have 2 passing tests. Excellent. Now we have 2 other of these tests that match this template, prefix and whence prefix. Now we already know how we can do that. CMRC add test, the name will be prefix, the source will be prefix.cpp, the resource, and we'll look at the file some prefix hello.txt, the resource will just be hello.txt, and the prefix will be some prefix. Well, we don't have an argument for prefix, so we'll need to also pass one of those. Prefix, and of course, forward that to the resource library. And the pass regular expression, since it's the same file as this, we can just copy its regular expression. Run CMake, run ctest, and now we have a third test that also passes. We can test if we give the wrong regular expression, and run ctest. The test fails because the output doesn't match the regular expression, that's bogus. Revert that, just checking. We also have a whence prefix, let's add one for that. This one expects both whence and a prefix. Compile, run ctest, and we have a whence prefix test there too. We have 2 more tests to define, one called flower and one called iterate. these ones are not as simple as the other tests, and they behave slightly differently. So let's add a test for flower. Its name will be flower. Its source will be flower.cpp. Its resource will be flower.jpg. So it gets a little tricky. This file does not output anything. It instead checks that the file we embed in the resource library is the same as the file we have in the source tree. And what we need to do is we need to pass the file path to this file in the source tree as the first argument to the test. So we'll have to do something a little different. What we need is a way to pass arguments to the underlying test. I'll call this argument test argv, and the path we want for this argument is the path to the file we need to check. If I run configure now, we get a warning because we have an unparsed argument, two in fact. Test argv and the path of the file were not parsed by CMake parse arguments. So what do? This one's not going to be a regular args. You can pass more than one argument to it because you might need more than one argument to the test. This will be a list arg. We'll name it based on what we passed, test argv, and now the configure gives us no warnings. How do we pass a test argv to the test? Well, that's just an additional argument to add test. I'm not going to quote this argument. As you can remember from the last video, we want list expansion to occur here. So it'll just be test argv. The argument name is test argv. The prefix is test underscore. I'll run configure. I'll build. I'll run ctest. And our new flower test passes. It opens and reads the file and does the checks. Our last test we have in this directory already is called iterate.cpp. This opens up the embedded file system and iterates over the contents of this directory, and it prints each file name as it goes through. So let's add a test for that too. Well, the only good way to test file iteration is to embed more than one resource at a time, but our resource argument only accepts one value. We'll need to change it. Let's call it resources, and the two that we're going to embed are these two files. And as the output, we expect these two file names. I'll run CMake. We get some warnings because these are not being passed as arguments. If I build and then run ctest, our child fails because it hasn't embedded the resource directories that we expected. We need to change the resource argument to be resources. So we'll take resource out of the args, put it into list args as resources. This message is wrong. It prints resources, and it prints more than one. And for this, we need to change it to resources as well. Now if I configure and build and test, all of our tests fail except iterate, because now we're no longer embedding any resources. And we can see we're getting lots of warnings because this argument has changed. It's now resources, so let's change those. Run CMake again, build, then run ctest, and all of our tests pass. I'll make a new test called enoent, and it will check that opening a resource file fails. For the enoent test, I'll simply copy the simple CPP and insert some exception handling. Change the resource library name to enoent, and in our open call, try, and I'll catch std system error. And if e.code is, you return 1. Otherwise, we return 0. So we check if the file opens. If we get an error on opening, we return 1 if the file does not exist, or we return 0 because we successfully opened the file. Now to define the test, it's similar to our others. CMRC, add test, name, enoent, source, enoent. We do not pass any resources. We do not pass a pass regex because we don't expect any output. Let's say that this test will fail. If I run, we see a warning about will fail because it didn't get parsed by arguments. This argument does not bind to any additional values, but its presence or absence is a Boolean value that we can use inside of our function, and this is what the options are for. The option name is will fail, and to tell ctest that a test should fail, we set the property will fail. CMake parse arguments will set the variable test will fail to true if will fail is passed and present in the argument list for the function. Otherwise, it sets this variable to false. Let's message the value so we can see it. Run it. For our simple test, will fail is false. For prefix, it's false. For all our tests, it's false, except enoent, where will fail is true. Compile, I'll run ctest, and Our enoent test passed by failing. There's one more thing to know about CMake parse arguments. Down here, we set pass regular expression on the test unconditionally, even for tests like flower and enoent, where we have no regular expression to pass. We're still setting an empty string regular expression. It's not strictly problematic in this case, but you want to do conditional setting. To do that, you check if defined and then the name of the variable test pass regex, and then we set the property conditionally. Just like that, our tests have pass regex only set when the variable is defined. If CMake parse arguments does not see this variable passed as an argument, it will undefine this variable that corresponds to the argument. That's most all you need to know about CMake parse arguments. With it, you can make very powerful custom functions and custom behaviors in CMake. The code for this file is very similar to the existing code in this repository. You can go look it up on my GitHub page. And by now we've covered a huge amount of all there is to know about CMake scripting. There's still a lot more to learn about the special commands you can run, but we'll be seeing those as we work with CMake more. As always, check the video description for any import links, addenda, errata, or more information. And until next time, keep CMaking good.